All right, now we are ready to begin the last part of the 7th grade curriculum. Woohoo! And that is 3D geometry. Now, the first thing we are asked to do is we are asked to classify them. So we're going to name them. Now understand, I'm going to be a real stickler about this. First of all, it's 3D geometry, so we use the word figure. We do not use shape. Shape indicates 2-dimensional. Figure is 3-dimensional. Now, there are two main types of 3D figures, a prism and a pyramid. You need to know the difference because I will not be happy if you get it wrong, and you will be marked wrong on the test if you label them incorrectly. Okay, so first is a prism. A prism is a figure. Notice again I use the word figure, not shape. It's a figure and it has two bases. That name the shape. That name the figure. And then the other faces are rectangles. Technically they're parallelograms, but I'll let you call them rectangles. Now, when it says two bases, the hardest thing for students to kind of wrap their brains around is understanding that the base is not necessarily the bottom shape. For example, this figure that's on the left, if we note, there's a face that's on the bottom and it's a rectangle and it measures 44 inches by 72 inches. Then there are two faces coming off of that meet up top, and that's why we end up with the triangles on the ends. The fact that this figure has two triangular faces, it is known as the triangular prism. It has two triangles. Therefore, that's what makes it triangular prism. This is the shape that students struggle with the most for anything we do for three-dimensional geometry. This is the hardest one. Everyone would look at this, I shouldn't say everyone, but a lot of students will look at this and say it's a rectangular prism because there's a rectangle on the bottom. The hardest thing for you guys is going to be training yourselves to get out of the thought that the face on the bottom will always be the base. Sometimes it will be, sometimes it won't. The thing to focus on is what are the faces? What shape is it and how many are there? When we take a look at this one over here, we note that we have two faces that are in the shape of a square. And since there's two of them, it makes it a prism. Therefore, this is a square prism. If it's easier to see, there's one square and we know there's one on the other side. Here's one triangle. And again, we know there's one on the other side. There's only two triangles or only two squares, and that's what makes it a prism. Now, for pyramid is a figure with one base that names the shape. That names the figure. The other faces are triangles that meet at an apex. Just like the city in North Carolina, except it's not capitalized because it's not a proper noun. So that very point at the very, very tippy top, that's going to be the apex. Taking a look at this first one, again, I'll shade the base for you. We know it's a quadrilateral. If we look, it measures 18 by 18. That tells us it's a square. There's only one of them, therefore it's a square pyramid. For this example over here, shade the base for you. Note that it's a triangle. It is called a triangular pyramid. There's only one base. Therefore, that makes it a pyramid. Now we're going to take a look at 3 additional 3D figures. However, these are all round in some way. Therefore, they are not in the general prism or pyramid. 2 of them are related to prism and pyramid, but because of the circular aspect and the round aspect, they do not get classified as prisms or pyramids. They get their own special names. The first one looks like a soup can. It is called a cylinder. A cylinder is a figure with two circular bases. Now, we don't call it a circle prism, but that's kind of what it looks like. And these two circular bases are connected by a lateral surface, meaning the round part on the side. So if you think about a soup can, the lateral surface would be like the label on a soup can. It doesn't cover the top and the bottom, the two circle parts, but it does wrap all the way around. It's the round part. When we unfold it, it looks like a rectangle, and that's what we'll get to in a minute. The next unique three-dimensional figure is a cone. A cone is a figure with one circular base. It is not a circle pyramid. The fact that it's circular indicates that you're not going to have any edges, therefore you don't have faces, therefore it cannot be a pyramid. It's one circular base and a lateral surface that forms an apex, again, just like the town down the road. The last one is a sphere. It is not a tool that is used when you go hunting in the wild. That is a spear. This is a sphere. It's pronounced like this, sphere. If you need to say severe, that's a lot closer than spear. A sphere is a figure whose surface is equidistant from the center, meaning any place that you touch on the surface of that sphere will be the same distance from the center, meaning the radius is going to be the same in all directions, including the three-dimensional part. Now we're going to take a look at the vocabulary term net. You are not catching anything. You are not going out and catching butterflies with this net. A net is an unfolded 3D figure. Now, think back to your elementary school days. You were handed those dull metal scissors, asked to cut out this figure, only cutting on the solid lines, not on the dotted lines. Then you were asked to fold on the dotted lines and glue them or tape them so that it made a box. And inevitably what happened? If it didn't collapse when you folded down the second side, it ended up collapsing when you folded down the first side, and you just became frustrated with it because it was not perfectly square. What you were cutting out were the nets to the figures. So for the cube, you can also note that this is very similar for the rectangular prism. A cube is going to be made up of 4 squares in a row, and that's what makes up the 4 sides around it. And then to get your top and bottom, you need a square on either side. So one on top, one on bottom. Location of those squares doesn't matter, as long as one's on top and one's on bottom. Majority of the nets for a cube or a rectangular prism is going to be in this arrangement or something very similar. For the triangular prism, we're starting in very much the same way. We have our 3 triangles, and we're going to pretend they're all equal. And then we have our 2 bases, and the 2 base triangles, one needs to go on top, one needs to go on bottom. The location doesn't matter as long as one is on top and one is on bottom. For the cylinder, we have our soup can label, and then we have a circle on top, and you have a circle on bottom. And that is what makes your cylinder, because the sides will wrap around and the top and bottom will fold in on each other. For the pyramid, easiest way to do the net for the pyramid is to draw what shape your base is. In this case, it's a rectangle, and we know that every other side is a triangle, so there's a triangle coming off of each side of the rectangle, and when we fold them all together, they form to that apex, that point, and that's what makes the pyramid. The last piece to the introduction to 3D figures is probably the hardest one for students to understand. A lot of times the students who are extremely visual learners do really, really well with this. Anybody who struggles with learning visually really struggles with this concept. A cross section is a 2D shape of the face when you slice a 3D figure. This means that if you are asked what the cross section is, words that you would use would be square, rectangle, triangle, oval, circle, are all examples of possible cross sections. Cuts that are made parallel to the base will take the shape of the base, meaning you're not going through the base, so whatever shape the base is will be the shape of your cross section. So in a rectangular pyramid, the cross section will be a rectangle. In a triangular prism, the cross section will be a triangle. When you're parallel to the base, the name of the figure gives it away. If you're cutting perpendicular to the base, the shape will take the face of, or will take the shape of the face. So it's whatever the other side is. Now there's a third one on here. Please note that it's exactly the same as cuts made parallel to the base will take the shape of. Please X it out. You don't need to worry about what's written at the bottom, because you've already done it.